Hi everybody. So this video is going to demonstrate on how to take your titration data from your chapter 2 lab and prepare it to plot it onto one single graph. So the first thing that we need to do is, if you all remember how we are going to plot our titration data, we need to have the millimoles of the titrant on the x-axis and the pH values on the y-axis. So what we obtained in the lab was volume of the, see if I could change my mouse here. What we should have obtained in the lab for all 4 of our different titrations, 2 histidine titrations with 0.5 normal HCl, 0.5 normal KOH, and also 2 DI waters, 0.5 normal hydrochloric acid and 0.5 normal potassium hydroxide, are volume of the titrants and also the corresponding pH values as well. This is kind of like old TF data that I was able to find. Just, kind of don't mind too much the lack of data points that I have here. But in any case, what we need to do is, in order to obtain how much titrant we used at each corresponding volume, we're going to have to add some, extra columns here. So what I'm going to do is, for every single titration, I'm going to add an extra column. And so I'll just go ahead and insert a row, or sorry, I should say there's a column right in between my volume and my pH values. And here I will put millimoles of titrant. So I'll just put millimoles, MMOL, as the units for millimole. All right, so how do we convert volume of titrants to millimoles of titrants if we know the concentration of our hydrochloric acid and also potassium hydroxide? So in this white space here, I am going to show you that calculation. So keep in mind that for monoprotic and monohydroxy acids and bases, respectively, so monoprotic or monohydroxy acids and bases. So for example, a monoprotic acid would be hydrochloric acid, just like we have here. And a monohydroxy base would be, 2 examples would be sodium hydroxide and also potassium hydroxide. Here, their molar strengths equal their normal strengths. So 1 molar of either of these titrants equals their 1 normal strength. If you want to know how this relates to polyprotic or polyhydroxy acids and bases, come to office hours or send me an email. But I'm just only going to cover these ones here because they're the ones relevant for our titration data. So if we have, for example, I'm going to use a different color now. I'll use blue. We have 0.5 normal hydrochloric acid. That is also equal to 0.5 molar hydrochloric acid. And molar has the units of, as everyone should know, moles per liter. So 0.5 molar hydrochloric acid is the same thing as 0.5 moles per liter, which is also the same thing as 0.5 millimoles per milliliter. So this is the concentration that we essentially want to use, and the factor that we want to multiply our volumes by, because they happen to be, as I didn't denote in this Excel spreadsheet here, the volumes that I have in here are in milliliters. So if I have a concentration already in millimoles per milliliters and I have milliliters, I multiply the two together and the resulting value will have the units of millimoles. So I just want to be explicit here in this, and this is volume in milliliters of the titrant. That's not going to allow it to fit that well, so I'll just copy that, paste it. Oops, it's too large. Paste it, and paste that as well to be consistent with my units. All right. So with that being the case, we know now that, you know, our titrants, half a normal hydrochloric acid and half a normal KOH, they have this units associated with them, 0.5 millimoles of the titrant for every milliliter that was added into our experiment. So I will go ahead while these notes are up on the screen. Under millimoles, I am going to set this formula, let Excel do the work for me, put in an equal sign, and then say 0.5 millimoles per milliliter times the volume that I have, which is going to be in this cell over one cell to the left. I press enter, and then the resulting value is going to be in millimoles. I highlight the previous cell that I had type the formula, and then over on the lower right hand side, I'm going to take that little square there and then just drag it through the entire length of the column. And I should get here the resulting millimoles of titrant for this particular volume. Since everything is in the same format here, I am going to now take that same formula, copy it because it is applicable to the same normal concentration of the base that I have there, and then just paste that. And instead of dragging it this time, I'm just going to hover my mouse over the highlighted column that I want to copy the formula for the entire column, and then just hover over that and then just double click really quickly, and then the entire length of the column gets populated with that value. Basically, I'll just repeat the same thing over again. Oh, another trick too is if you have the formula copied, you can just highlight the destination cells as well. And if you do a quick Control V for paste or right click and hit paste, then those cells will also get populated with the values as well. All right, so kind of like I've done like a little bit of half the work already. I now have millimoles of each of my titrants and also their corresponding pH values. However, the data isn't really in a good format for me to plot all of the curves on the same graph. And I have to merge both of my histidine titrations and both of my water titrations in the same values, or I should say, sorry, kind of like in one complete flowing data set. So what I'm going to do now is I'm going to set over here. I'm going to make things just a tiny bit smaller, narrower. I don't want to zoom out too much. For these titrations, I'm going to set up one complete histidine titration. And then another column for the complete water titration. But what I have to do is I have to lay out my data going from one end of the titration curve to the other. And so the tip that I have is make your acid titration values negative. And the way that we're really going to do that is essentially I'm going to, what's a good way of doing this? basically going to copy over my histidine acid titration first. And I'm going to copy this and then paste it over my under my histidine titration. Now the first column on the left, this here is my acid titration, the millimoles of the acid. And I said make these negative. So what I'm really going to quickly do is over on this left column over here, I'll say I want this equal to the negative or just minus sign value of this cell here. So I'll just put equals negative Q2. I hit enter. Negative 0 is still 0. But then, I'll drag the rest of the column down, and I end up really quickly converting all of my titrant, millimoles of titrant, of acid titrant into negative values. I'm simply going to cut this entire selection and then just paste it over my titration values. Oh, and Excel got upset at that because that was a formula that I had copied, and now there's no reference for it. So I'll undo that really quickly. I'm going to copy it again, and then here, instead of pasting the formula, I'll just go ahead and just tell it to paste the values. So it just pasted the entire values, and of course the formula updated, and it's taking the negative and negative, which reverts it back to positive. But I don't need this column anymore, so I'll just highlight it and delete it. I'll do the same thing for my hydrochloric acid water titration. I'll take the millimoles and the pH values, copy those, paste them over, and oh, I got very upset with that for whatever reason. Yeah, sorry, I should copy those values because the first column is a formula. I'll copy those values and just paste the values. I'll copy that data and just paste the values, and then just do the same thing over again. Equals negative, whatever that cell is. Expand it. I don't need all of these zeros here. I'll take these values, copy them, and then just essentially paste just the values, and then get rid of these formulas over here. So now what I have is my hydrochloric titration values in negative, and my water titration values also for the hydrochloric acid titrant also a negative as well. For the base, for the potassium hydroxide, the millimoles of potassium hydroxide and corresponding pHs, I'll just highlight those, copy the data, and then right beneath their respective titration columns, the combined titration columns, I'll just paste the values as is. And do that here, copy this, just paste the values because I do not want formulas being carried over. So if I go ahead, now I'll just move over because this is kind of like the main part of our graph. If I go ahead and graph these two titrations, it's gonna look funky. So insert a chart, I'll do scattered with curved lines, and now it's time to select my data. I'll right click on the empty graph, hit select data. I'm gonna add a series. The name of this series is histidine buffer titration. My X values, I'm going to select as, I'll put equals, and the millimoles of the titrant, the X values, will be this entire column here, top to bottom. And then the Y values, let me just delete this equals 1 in the braces there, put an equal sign, and then select the corresponding pH values there. Once I do that, I can see hitting OK that I get a really funny, for the most part, it looks nice, but I have this like weird line here. And this weird line is because your values for the titration curve, they're not in numerical order for the X value. So for example, here, it started at 0, and then it's going over to the negative region. And then when it gets over here, after negative 7.25, there's nothing left. It goes back to 0. That's that line that you see there. So if you don't put your values for the millimoles of titrant from the least negative number going to 0, going to the highest positive number, then you're going to get a really funky curve, something like this. But this is a really quick fix. You don't need to do a lot of more copying, pasting. All that you need to do is select both columns at the same time. So I'll just start on the upper left over here, hold down the shift key. Actually, no, scroll down, then hold the shift key, and then click on the lower right cell in the column. And both columns from top to bottom, except for the histidine titration label up there, they should be highlighted. And then what I'm going to do is I'm going to sort my data with this sort button here. And I'm going to say my data does not have headers, meaning I want to include the values that I had originally highlighted. So I'm going to uncheck that. And then sort by column Q first. And this is going to sort those titrant values from smallest to largest, meaning the smallest negative value to 0 all the way to the highest positive value. And that's all I want. So when I hit OK, then everything is now in order. I go from the highest amount of acid to 0 to the highest amount of KOH, and I end up getting something really nice. No weird, funky zigzag lines interrupting or anything like that. I will note that because you did 2 separate titrations, one with acid, one with base, you will have probably different starting pH values for no titrant added. You should have 2 0 titrant starting pH values. If that's your case, I would just recommend take these 2 starting pH values and then just average them into 1. So for example, here, if I had like 3.80, and this one was, well, I'll just do like 3.81. And then for my basic titrant, this was like 3.84. And they might not even go in order. This one might be like 3.92, and this one over here might be 3.84. You know, when you zoom into your titration curve, I don't know if we can do that without upsetting Excel too much. Yeah, it's getting really upset. You might not notice this until you're like really zoomed in, but if you have 2 different starting pH values for both titrants, then what I recommend is just basically take the average of these 2. So for example, equals the average of, and then I'll just highlight both of these numbers, close up parentheses, hit equals. I'll just take that value, 3.88, and just write it over here, 3.88, so it's not a formula anymore. I'll delete this. I'll delete one of the starting titrant values, move up, and then just represent the starting pH value for the titration as that average of the average of the 2 starting values, 3.88. So you can do that for your data for this post-lab write-up. I'll do the same thing for the water titration, but I want to put it on another on the same graph. I don't want to put it on another graph. So what I'm going to do is go back to select graph, make a new legend series entry, add one. This is going to be called, you know, DI water titration. My X values will be this entire column here. My Y values, getting rid of this equals 1 there. Highlight this whole column here. I hit OK. And this looks fine for the most part, but I'm sure if we zoom in, we're going to see something really weird because our values from top to bottom for the millimoles of titrant are not going in numerical order. So again, I will just highlight my data, hit sort. I want to sort by column T, so I'll select column T. And then the order I want it to go from smallest to largest. When I do that, I don't know if you noticed, but like there was a little thickness over here because of that weird zigzag line. It's now gone, and we end up getting these nice two curves, a water titration, which is going to be kind of like skinny with like a rise on the right side of the vertical axes, the y-axis, and then kind of a low dip, a very narrow low dip over on the left side of the y-axis. And notice that, of course, for this TF data, we did not take as many points as we should have. And so this is, you know, we get this like pretty incomplete titration curve here. But hopefully these tips here will help you allow you to put your histidine titration and your water titration curves on one single graph. You know, aesthetically speaking, if you want to change it up a little bit, you're more than welcome to. If you double click on the horizontal axes here, you'll get the format axes window. Some of you who probably do not like seeing the vertical axes, or sorry, I should say the y-axis intercepting your titration curve. You want to make it look like the titration curves that are more best represented in your books. You may change the vertical axis cross to a specific value. So for example, if you want to push the axes all the way to the left side, I would change it to -10. And doing that, you know, if you push the y-axis all the way to the left side, that's fine. If I want to push it all the way to the right side, I could probably change this all the way to 40. It's up to you, however you want to do this. But what we do require for this one graph, I believe it's prompt B, or not B2, sorry, it's going to be A2. No, it's B3. You want to plot your titration data, millimoles on the x-axis, pH on the y-axis, both of them on the same graph. And just make sure that in your, not only in your x-axis label here, so I'm just going to go ahead and add this chart element, x-axis, primary horizontal axis title. You need to put down as much information as you can. So of course units are important, so we'll put millimole of titrant, but people aren't really going to understand what you mean by negative and positive titrant. I'll hit enter on my keyboard once and then put parentheses. I'll say negative equals 0, HCl, positive equals KOH, potassium hydroxide. And then add a y-axis label as well, and you know, write as much as you can in the description, and you should be pretty much set for this particular prompt.